So today we're going to talk about what is a logarithm. What is the definition of a logarithm? So log base b of x is defined as the inverse of f of x equals b to the x. So for any specific b value, you can take that exponential function, and it'll look something like this. And it's 1 to 1, and because it's 1 to 1, it has an inverse. That inverse is going to be log base b of x. Common log is specifically log base 10 of x, so that's the inverse of 10 to the x. Natural log is written like this, but it's specifically the inverse of e to the x. And you'd never write it this way, but you could theoretically write it log base e of x. And if I had something like log base 6 of x, that's representing the inverse of this. So what would this look like in terms of a function? Well, if we plug in different x coordinates, so plug in x equals 0, 1, 2, 3, 4, what we get out is, well, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and 2 to the fourth is 16. And then the inverse function, well, the way that works is just you switch the x and the y values. Any x comma y coordinate pair is going to be the opposite xy coordinate pair here. So 1, 2, 4, 8, 16 are the inputs, and the output would be 0, 1, 2, 3, and 4. So if we graph these, we know that this has an asymptote at 0, y equals 0, and then we have a y-intercept of 1, and then we go up to 2, 1 comma 2, 2 comma 4, and then 3 comma 8. So that would be getting off the graph. And this is more or less what it will look like. If we do the inverse of that, well, each of these points switches places. So we go to 1 comma 0, 2 comma 1, which would be there, 4 comma 2, which would be there, 8 comma 3, 6, 7, 8, comma 3. So it looks kind of like a square root function, but just like before, we have an asymptote, and instead of y equals 0, now we have it at x equals 0. So this is what a logarithmic function looks like. Thanks.